All right, guys, so are there any questions on any of the assignments thus far? Or, well, assignment, because there's only been one. Okay. What we are going to continue on with today is finding the product of these rational expressions. Now, we did one of these yesterday because we did monomial terms, because each rational expression had a monomial term on top and bottom, just had one term, didn't have anything added and subtracted. We did several of those, and then we did one where we actually had more than one term, so we had a few trinomials and a few binomials. Trinomials just means 3 terms, and binomials meaning 2. And we look at these here, and we're multiplying them together. The first real thing that that's helpful in simplifying these is to factor them down. Because if we tried to multiply them, and we didn't do this yesterday, straight across, and doing 5x times our x squared, our negative 5x and 6, it would make them bigger, and then we would actually need to factor them down anyways. So it behooves us, and it kind of helps us out if we factor first. And if we look at these 4 spots, or 4 sets of terms, well, 5x is going to be by itself, because there's no other terms with it, so it's not going to factor down any further than it already is. Now, probably the next easiest one to factor is going to be our 5x minus 5x squared. What do we notice that is the greatest common factor between these two terms here? 5x, yes? And if we factor this out, well, wait a minute. The x squared, the biggest term, is negative, isn't it?
Charlie Prater, please come to the office.
And if we factor out the 5x, that's fine. That does work out. But it ends up leaving this bigger x, because that'll just end up being x. Well, I'll use a highlighter. Because if y'all are ended up watching this back, you have no idea what I'm pointing at. This negative 5x squared, if we factor the 5x, is going to become what? Negative x, yes? And when we look at the rest of them, well, the x, when we factor, should be what? Positive, yes? So most likely, whenever we're dealing with this kind of scenario, it might be helpful to factor not just 5x, but what? Negative 5x. Because if we can keep all the variables positive, it's going to make it easier when we factor the rest of it. So if we factor a negative 5x out of both of these terms here, and I'll write it a little backwards, and we can flip it when we write it again, when we multiply them together. Negative 5x out of positive 5x is going to give us a negative 1. Because the 5 factors out completely, the x factors out completely, which would leave us with 1, a positive 1, but because we pull a negative away from it, it changes it from negative to, or positive to, negative. Now the next one is negative 5x squared. Well, if we factor that negative out, it's going to become positive. The 5 will factor out completely, and we'll take 1x away from x squared, which leaves us with plus x. And we'll rewrite it when we multiply and actually switch it to x minus 1. But I wanted to leave it in this form so that we're not just doing a factoring of 5x, a factoring out of the negative, and flipping 2 terms all in one go. Because that can be a little much at times. Now we need to factor the other 2 trinomials. Which one do we want to factor first? So the x squared minus 5x plus 6. So we look at this here, because the third term, the 6, is positive, our signs are the same, and they match the sign of the middle term, which is negative. So we'll have a negative and a negative. Now the factors of x squared are x and x. Now you look at the factors of 6. 1 and 6, or 2 and 3. And the ones that would work would be 2 and 3, And if we did check this, it would be negative 3x minus 2x gives us a negative 5x. So those are the correct factors. And that does leave us to the last one here, x squared minus 4x plus 3. Well, since the 3 is positive, our signs are the same, and they match the sign of the middle term, which would be negative and negative. The factors for x squared are x and x. Well, the only factors of 3 are 1 and 3. Now we can multiply all this together. Well, on top we'll have negative 5x times, well, we can switch it to x minus 1, times x minus 2 times x minus 3. On bottom, we'll have the 5x, x minus 1, and x minus 3. Now, what's going to simplify out? X minus 1 and x minus 1. The x minus 3 and x minus 3. Anything else? Now, the 5x and 5x will simplify out, but the negative doesn't. The negative will still be there. So we'll still have the negative. And what else? X minus 2. Now, since everything else simplified into the denominator just becomes 1, but we don't write the division of 1. We just leave it as negative, parentheses, x minus 2, close parentheses. And that's it. That's all we have to do for this here. Now, if we did want to look at the restrictions, because we didn't talk about that with the first one the other day, it would just be looking at what's going to make these 3 spots here be 0. Well, for x minus 3, it would be a positive 3, because 3 minus 3 would be 0. For the x minus 1, it would be 1, because 1 minus 1 would be 0. And how about for the 5x? It'd be 0. So the values that this could not be would be 3, 1, and 0. Any questions on this here? All right. So we're still going to look at some more of these here. So the next one we're looking at is this one here. 2x squared minus 10x over x squared minus 25 times x plus 3 over 2x squared. Well, we do need to factor these here. So let's look at the 2x squared minus 10x. Well, we only have 2 factors, yes? Or 2 terms? So most likely we're not going to use 2 sets of parentheses, but is there a greatest common factor? Anything else? X. Because 10 and 2 do have a common factor of 2 that can divide into both, and x squared and x do have a common factor of x. Now, if I factor 2x out of 2x squared, I'm left with x, and then we have minus 5, because the 10 divided by 2 would be 5. The x would factor out completely, so we're just left with 5. Do we want to do the x squared minus 25 first, or the x plus 3? Okay. X squared minus 25 is a what? Difference of perfect squares, yes? So that would factor to be x times x plus 5. So we'd have x minus 5 times x plus 5 would be the factorization of x squared minus 25. And I think that's slowly becoming y'all's favorite one to factor, if you have to factor them. So we've taken care of the first rational expression. If we look at the next one, x plus 3. Can we actually factor that? No. The degree is 1, and there are no greatest common factors. So that's as far as we can take it. On bottom, the degree is 2, but how many terms do we have? 1. So that can't factor any farther than it already is. Well, we can go on and multiply these two together. So on top, we're going to have 2x times x minus 5 times x plus 3. On bottom, we're going to have 2x squared times x minus 5 times x plus 5. So let's see what's in common on top and bottom. Well, we have x minus 5 and 2x. The 2 does cancel, but do the x cancel out completely? No. We only eliminate 1 on bottom. So I rewrite over the 2 with a 1. Essentially, I reduce it by whatever the amount is. So if there had been like 5 on bottom, I would just kind of rewrite a 4, showing that it's been reduced by that amount. So what that leaves us with is what on top? X plus 3 over x times x plus 5. So this time we actually do have something left in the denominator. And it can be the case that it works out this way here. And that's kind of why I wanted us to at least do this one also, or have this one in here. Because the ones we did at the beginning, everything eliminated out of the denominator, and we just had the numerator left over. Any questions on this here? We ready for the next one? Looks more difficult? Well, let's take it one step at a time and see what we have. Because when we look at this here, the first, we have c to the third plus 8 over c to the fifth minus 4c cubed times c to the sixth minus 4c to the fifth plus 4c to the fourth over c squared minus 2c plus 4. Okay. For this here, the factoring might take more than one step, because up to this point, we've been able to factor it all in one go, and we were just fine. Here, we might need to do some factoring first, and then see if we can factor again. So we're not going to try to do some of these, like c to the fifth minus 4c cubed, do that all at once. Or c to the sixth minus 4c to the fifth plus 4c to the fourth. Because have we factored anything with a sixth power or fifth power yet? No. But we definitely have done c cubed plus 8, because that is a sum of perfect, what? Cubes. Because 3 would be cubes. Because the cubed root of c to the third is, and the cubed root of 8 is 2. So we would have our small set of parentheses and big. The small one's going to have 3 spaces, and the big one's going to have 5. And the first thing we did was find the signs. And our signs always went the same, opposite always end on a positive note. So the same would be plus, opposite would be minus, ended on a positive note with a plus. Now, since c came first, we'll plug it in first for its first set of terms. In the first set of parentheses, it would be c. And we would have c squared, c, and c to the 0. Then we would plug in the 2's, because we would have 2. We would multiply the middle one by 2. And then over here we would have 2 squared, yes? That looks familiar, doesn't it? That bigger set of parentheses? Where do we see that? We have c squared minus 2c plus 4, yes? We might not have to mess with that one, right? And that actually also tells me something else. Let's go on in. Give yourself a little bit of room. We'll put the next 2. Because here we see that this is c plus 2 times, this would be c squared minus what? c plus 4. Okay, so that does exactly match up to the one down there, yes? And one thing I did say about the sum and difference of perfect cubes was that the quadratic part of this, so here it'd be the c squared minus 2c plus 4, doesn't have real solutions. If it doesn't have real solutions, it means it will not factor. And if it matches up to this one here, well, if it's going to jerk the page, this one here, it means this one here will not factor either. But it also really doesn't matter. Because if it already matches up to one that's being multiplied on top, this one cancel out anyways. And this is being multiplied into the group. And we can put parentheses around it. We don't need it at this point, but we can have it anyways. Okay. Right in black for these here. We do have 2 left, yes? And whenever we factor, the first thing we looked for was what? A greatest common. Now looking at c to the 5th minus 4c cubed, is there a greatest common factor between them? C cubed. There are c's in both spots, yes? So I can factor out as c to the 3rd from c to the 5th and 4c cubed. If I factor out c to the 3rd from c to the 5th, I'm left with c squared minus 4. Well, that's kind of nice, isn't it? Because once I pulled out that c to the 3rd, I'm left with c squared minus 4. We know how to do that one. That's a difference of perfect squares, yes? Well, if we're going to already working with it, might as well continue it out, if it'll let me. So we would have c cubed times what? So c squared minus 4 would be, come on, would be c minus 2 times c plus 2. Because c squared minus 4 is the difference of perfect squares, which should be our c minus 2 times c plus 2. So we kind of had to do that one in 2 steps. We had to factor out the greatest common factor and then factor c squared minus 4, what we had left. Well, with that in mind, is there a greatest common factor between c to the 6th, 4c to the 5th, and 4c to the 4th? C to the 4th. And if we factor this out, we're left with c squared minus 4c plus 4. Well, that there will factor, yes? Since the third term, 4 is positive, the signs are the same and they match the sign of the middle term, which would be and negative. Our factors of c squared are c and c, 2 and 2. And we get to this here. Well, the next thing is we have to multiply the numerators and denominators together. Now, I'll always put, if there's just single terms being multiplied by any of the sets of parentheses, I'll put them out front. So I'll put the c to the fourth out front. We have c plus 2 times c minus 2 times c minus 2 times our c squared minus 2c plus 4. On bottom, we're going to have c to the third times c minus 2 times c plus 2 times c squared minus 2c plus 4. Any questions on this here before we start simplifying? So, well, c squared minus 2c plus 4 will cancel out with c squared minus 2c plus 4. What else? C plus 2 and c plus 2. And c minus 2. C cubed rule do c to the fourth 2, c to the first, because our 4 minus 3 would be 1, and since it's bigger on top, it'll stay on top. And let's see what that leaves us with. Do we have anything left in the denominator? No, so it's just going to be 1. We don't have to write anything there. But in the numerator, we do have c times, and that's it. So is this here any different than what we've been doing? Was it any harder? No. We just had to use different factors and different steps to get there. Okay? So what do we do first? Cubed root of 3. X cubed would be 3. Because 3 times 3 would be 9, times 3 is 27. So the cubed root of 27 is 3. So that means we can take the cubed root of this. And our signs would be same, opposite, always and on a positive note. So negative, plus, plus. We can plug in the factors for the first term, which would be x. Here would be x squared, and then we would have x. Then we would have 3, 3, and 3 squared. Do we want to finish factoring the rest for the first step, or do we want to continue on with the cubic? Finish the cubic. Okay. So we can go on and put our second set right here. So in the first one, we would have x minus 3. And then we would have x squared plus, plus. Same as this one over here, x squared plus. So most likely that one there won't factor. But even if it did, it doesn't matter because it will be multiplied with the rest of it and cancel out with the one on top. Let's look at the x to the fourth minus 9x squared. What can we do first? We can factor out the x squared, which leaves us with x squared minus 9. I have a feeling you all want to finish this one out. So we still have the x squared. X minus 3 and x plus 3? Yes. Because that would be the difference of perfect squares for x squared minus 9. And lastly, the x to the fifth minus 6x to the fourth plus 9x cubed. There's an x cubed in all three terms. which would leave us with x squared minus 6x plus 9. Our signs would be and negative because the third term is positive, so the signs are the same and they match the sign of the middle term, which would be negative and negative. Factors of x squared are x and x. The factors of 9 are 3 and 3. Any questions on any of this here? I feel at this point y'all feel pretty comfortable or more comfortable with this here. Now, personally, I don't rewrite this together as we've been doing on the last few where we multiply it and have it all written together all nice and neat. Yes. Because what do we know? When we multiply, we're multiplying straight across, yes? So essentially they become 1. Which means that I can say, and let's get a creative pen, that this x minus 3 here, and this x minus 3 here will go away. The x squared plus 3x plus 9 will simplify with the x squared plus 3x plus 9. And this x squared will simplify out completely with the x cubed. 1x or x to the first, either one. Now, is there anything else? No. And this time we are left with something on bottom. And on top we have x times x minus 3 times and that'd be it. Any questions on this here? This is the last type that we're going to look at with multiplication. What it is, what is the denominator for x squared plus 3x plus 9? As a division of 1, we don't really write. Now, I write this in just as kind of a reminder for us. Whenever we multiply these two here, this entire set of parentheses is being only multiplied by the numerator. We only multiply by the top when we don't have a denominator for the other term. Because realistically, the denominator for the x squared plus 3x plus 9 is 1, which would be multiplied by the denominator. So if we looked at the multiplication here, well, this part here would be 1. The numerator for the first one is just going to stay x plus 2. Because most likely this here will be the cubic part of our perfect cube trinomial. And we had it right here, didn't we? So, as we saw in the previous problem here, this is going to factor down to x minus 3 times x squared plus 3x plus 9. And that's kind of what we saw already. We can make this into 1 where these would cancel out, leaving us with over x minus 3. Because again, sometimes and a lot of times, the other factors will tell us what we need. Any questions on this here? So I think we have a few more, and I think one more will be good, yes? Or are these the last two? Which one do y'all want to do over the others? This one here? Okay. When we look at this multiplication, we know the x minus 7 is already factored. And we know the denominator of the second term is going to be 1. And we can put it there just as a reminder. What do we suspect about the x squared minus 2x plus 4? It's going to cancel out. It's not factorable. It's the unfactorable part of our sum of perfect cubes. So I will leave it here. We'll go on and make that assumption and factor this here. Because the square or the cubed root of x cubed is, and the cubed root of 8 is 2. Okay, that does kind of line up with this quadratic part. Yes, because the square, the first term is just going to be x squared. And we know the last term is going to be our 2 squared, which is 4. So this would be our 2x, and it would be negative. Because the signs would be the same, opposite, always end on a positive note. And the first two terms that we're missing are going to be x plus. And it's good to just at least make sure and check through that that is what they would be. Just in case for some reason they decide to just throw in and make it so that it left that quadratic in there till the end. Now, as we were saying, these two here will cancel out, leaving us with what? Over. And that'd be the answer. Any other questions on this here? And that is all we are doing for today. And that finishes up 7.31. So we did simplification and multiplication. On Monday, what do you think we'll be doing? Division. It's actually going to be almost exactly like this here. Because what is 1/2 divided by 3/4? What would we do? Well, we don't do division, we change it from division to and flip the second and then multiply. And we'll do the exact same thing with these here.